Hello, everyone, and welcome to Northern Shield Resources live event hosted by Six. I'm pleased to introduce their speaker for today, President and CEO Ian Bliss. Ian will walk us through their latest press release and presentation, and after that, we'll be accepting questions. As a reminder, you can submit your questions in the chat at any point during the presentation on the right-hand side of your screen. As always, the summit is being recorded and will be available on six.com to watch afterwards. So without further ado, I'll hand things over to you, Ian, to get started.
Thank you very much, Kyle, for that introduction, and good afternoon, everyone, or good morning, depending on where you sit in the country or the world. This is just a very brief update on the news release of last week with a question and answer period following, which I'll leave most of the time for that Q&A session. So I'm not going to go through a full presentation. I'll just use a few slides as a backdrop. As the press release indicated, we completed 8 drill holes totaling just over 600 meters, focused on the conquest zone of Root Cellar. The map here shows the location of those drill holes, number 23 RC 15 to 19. Obviously, most of the work took place down in this area here, where we had a known trench from originally the Discovery Trench, and just prior to the drilling too, that's where we're finding a lot of visible gold, as indicated by the red and white stars. And as indicated in the press release, 3 out of the 8 drill holes intersected visible gold, with at least 2 occurrences in 2 of those drill holes. But just as importantly, 7 of those 8 drill holes hit mineralization consistent with a low sulfidation epithermal gold system. The only hole that was not particularly successful was hole number 19, targeting this IP anomaly at depth. This is what we call an offline anomaly. So this is why there's a little bit of ambiguity in its exact position. The survey line is here, and it sees something off to the side, but when it sees targets off to the side, its positioning is not that accurate. So obviously we have to go back and figure out a little bit more of why we missed there. The interesting thing is, on surface, we do have a structure trending the way we want to see it northeast. That's gold anomalous. And so perhaps later on we'll get a little bit closer up to these surface showings and hit them more shallow and then follow it down to depth. But I say the main mineralization, where all 7 holes down in here hit mineralization consistent with an epithermal system. And so one of the key takeaways from this, other than, of course, the visible gold, is that all the mineralization we hit here is within 40 meters of surface. So for some time, we've been talking about the potential for a near-surface resource at Root Cellar. And this highlights that potential. We obviously have to wait for assays, but we do have visible golden core, and it's going to be surprising if the assays don't come back with some at least modest levels of gold. So all mineralization in this program hit within about 40 meters of surface, as I highlighting that near surface potential. As we go on through further programs, we'll start tracking these deeper and deeper, as well as expanding that near surface resource potential. But one of the critical things as well is the textures and the chemistry that we see from previous samples tell us that we're still high in the system on the top level of the boiling zone, and yet we are seeing visible gold. And that's an extremely important point, is we're probably not yet into the heart of the system, but we are seeing gold. And that's an extremely encouraging point, the fact that we're seeing so much gold sort of just on the envelope of the main boiling zone, where you expect to find most of your gold. And we also see a very complex array of breccias. So you always tend to think of these low sulfidation systems as these nicely colorful and cross-form banded quartz veins. They're not all like that, especially those in an extensional regime. You get a lot of brecciation. Some deposits around the world, most of the gold ore in these low sulfidation systems are in brecciated ores like this, and not in the classic crustiform coliform banded veins. I say that we see these are really complex core to log, from what our geologists say. I mean, you see brecciation, you see a breccia within a breccia within a breccia. And that's also very important, because every brecciation event is the same as a band in a crustiform vein. It's basically another pulse of fluid, and every pulse of fluid, every hydrothermal event has the opportunity to bring more gold and obviously upgrade the system as it goes along. So repeated brecciation, that's what we're seeing. is a positive sign, as it provides the opportunity to keep on upgrading both the size of any deposit and certain the grade. I say the drilling also targeted a combination of IP targets, mostly near surface IP targets, but they're also fairly near resistivity low. And I'll move on to another map in the middle. Say this background image here is from a depth of 80 meters, so it doesn't play too much into the near surface mineralization we're hitting, other than it seems to suggest that something at depth is feeding the mineralization that we see on surface. So just moving on to, so I'll move on to this image here. If you look on the right hand side, this is the resistivity map, and you see all these dark colors are actually resistivity lows. Again, typically in low sulfidation systems, you're looking for resistivity is high, something very resistive, because quartz and silica is resistive. But epithermal systems also produce a lot of clays as the alteration product, and those are weakly conductive or low resistivity. So all these dark purple colors indicate areas of low resistivity, and that's where we've been drilling in here. You can see a very distinct contact between sort of this T-shaped resistivity low and where we've been drilling and getting good-looking gold, potentially gold mineralization. And say that low resistivity low is probably created by the clays associated with these breccias, both within some of the mineralization and as a sort of an alteration product on the sides of these. So going forward, we're going to start prioritizing some of the chargeability anomalies that are associated with these very, very distinct resistivity lows. This one over here, for instance, is a really nice one because it's one of the strongest resistivity lows we have. And actually underneath it, when you look at the sections, it's the strongest resistivity high we have. So that would suggest that you have your clay alteration at the top of the structure of the vein system. And below that, you may have an area of very strong solicitation, or perhaps a proper, fairly wide coliform crustiform banded quartz vein. So this drill program gives a lot of new information on a variety of fronts, both the geology, the mineralization, the lithology, and certainly the geophysics. And there seems to be a close correlation between some of the mineralization, certainly that we're seeing in the drill core in this last program, with resistivity lows. And certainly there's chargeability anomalies in these areas as well. And so I say we will begin to target chargeability anomalies associated with some of these resistivity lows. And I say this background map, all these little white lines are just quickly sort of superimpose the chargeability anomalies onto this resistivity. So you can see these are some of the chargeability anomalies that correspond to some areas of resistivity. And if you look at this map on the left-hand side, again, these little blue lines are those same IP anomalies related to the resistivity. The red bubbles are soil samples, and you can clearly see how some of these soil samples, anomalous in gold, follow these IP anomalies. And they're not quite parallel. They all seem to sort of radiate from a point back in here, which may be a volcanic center. In fact, I think quite likely it's one of the eruptive centers, and these are radial fractures that some volcanic eruption would have created that the gold-bearing fluids eventually migrated into. And as I say, you can see, again, going back to the resistivity and the chargeability, underneath this probably clay alteration, this low resistivity, you have a really nice chargeability anomaly. The same sitting over here, just west of where we're drilling. In fact, one of the holes, the latest hole that had VG at the top, has a nice chargeability anomaly. It seems to be coming down the left-hand side, the west side of the vertical section of this T-shaped resistivity. So one of the other things that we began to pick out in this, and this was one of the benefits of drilling a lot of holes in a fairly small area, because we do see, say, a very drastic change in the geology, or more specifically the mineralization. I mean, we're seeing textures in drill holes drilled a few meters at depth that we don't see in outcrops. So it's a very significant change both laterally and with depth, with textures. And that could also bring about a change in gold content. And so it's important to drill a lot of holes in a fairly small area. And so all the red bands along the trace of the drill holes are approximate indications of mineralization projected up to surface. This sort of transparent red area is an area that I've tried to highlight that shows we're seeing a variety of styles. One of the intercepts that we're seeing, we believe, is fairly flat line, and basically it's or in this case, dipping to the south. But it's forming at the contact of two different geological units. Say most of these systems are structural hosted, but in this case, part of it seems to be exploiting a weakness. So this red shaded area is that what we call a stratabound style of mineralization. And again, we've been able to pick out the lithology a little bit better. Where that projects to surface is up in here. So we've already got gold up on surface here, and that's where this will project. So if you look at this left-hand or the right-hand diagram, it'll be a cross-section across that zone from south to north. And so it's basically at the contact, basaltic rocks and acidic rocks. And I say we're getting some of that mineralization actually shaded in here is what we call, what we're labeling as stratiform mineralization. Now, again, the complexity within that is on top of that or below it, there's also structural mineralization, which is really what we're after. And so we got to start filtering out and figuring out which one of these intersects are structures. And again, there's two sets of structures, east-west and north-south. And some of these line up quite nicely in north-south. So you will have on this profile structures that are beginning to get mineralized on top of this stratiform layer. There's a key component of this too is we have these rhyolite spires that seem to have, basically they're just like dikes. They're a rock that's been formed after these two have been solidified, or at least emplaced. And so that these fluids are basically exploiting what we think of the same fractures as that rhyolite dike. These rhyolite dikes form little domes at what would have been the original, what we call a paleo surface, a lot of brecciations. And these are tuffs. These are ashfall rocks made up of fine ash particles settling after a volcanic eruption. They're very porous, so they allow the fluids to sort of mingle with these breccias created by these rhyolite domes plus the ash. And I think that's why we're seeing some mineralization along here. And the closer you get to these rhyolites, it seems that you're getting these better looking rocks that may carry some of the higher grade. So one of the things we did learn is we didn't now decipher the different mineralizations that we hit in these drill holes. And from what we can see so far, this area in here, and it probably continues to the west, we just don't have drilling in here, but this would be the surface expression of the stratiform horizon that we began to pick out, which does, as I say, would extend up to surface here, and it follows all the way to the east to some of the drill holes we've drilled in the past. And so we can again look at this with chemistry from last year's drilling in a different area. We started to pick out certain characteristics of it that help us to discriminate, the stratiform mineralization from the structural mineralization. So that was one of the key sort of takeaways from this program. So I'll really end it there and start answering any questions you may have.
Perfect. Okay. Thank you, Ian. And thank you, everyone that's tuned in. If you tuned in a little late, just a reminder, this is a Q&A session that you could submit questions in the bottom right corner of your screen. We did have some questions submitted on chat forums and via email, so I'll get to those first and then address the ones in the chat. First question for you, Ian. What distinguishes the Shot Rock epithermal gold project in Nova Scotia that looks so promising and Root Cellar?
Well, there's a bunch of criteria in geology, but the real takeaway differences from Shot Rock and Root Cellar is, first of all, at Root Cellar we have a lot more gold on surface than we did at Shot Rock. We also have higher grade. I think the highest grade we had at Shot Rock was 5 grams on surface, and obviously we have up to 111 grams per ton. So we have a lot more gold mineralization area-wise and grade at Root Cellar than we ever had at Shot Rock. But the key difference is at Shot Rock, we had a successful first drill program, but as we continue to drill at Shot Rock, we continue to hit classic coliform crustiform veins that contain a mineral called adularia, which is a key ingredient, which tells you you're at the right depth within the boiling zone. Yet a lot of these veins, despite having the right criteria telling us that we're in the boiling zone, did not carry significant gold grade. And so once you drilled a few programs that consistently saw the same results, it's basically indicating that it wasn't a fertile system, because we should have been getting gold in those crustiform coliform banded veins, but we weren't. Whereas at Root Cellar, we're barely into the true boiling zone, and yet we're seeing significant gold grains. And even with with the coliform banding veins that we do see, they carry visible gold. So that's the really key ingredient here, and it's a good takeaway that at least we're seeing gold where we're expecting to see it. And I say we're only on the fringe of the system, and that's what we believe, and we're seeing a lot of gold. Whereas at Shot Rock, we were into the heart of the system, and we didn't see the gold at the end of the day.
Right. And you mentioned that Root Cellar is an extensional structural regime. What's the importance of this?
Yeah, good question, because gold in these systems is created by a boiling event. We tend to think of boiling at home as simply turning on the heat under your kettle or pot of water. But boiling in geology is really a function of a change in pressure. If you remember your days in school in physics, how if you went to the top of Everest and you boiled a pot of water, it boils at a lower temperature than at ground level. You go deeper into the ground, it boils at a much higher temperature. So in these systems and in geology, that fluid is always super hot. And the way to get it to boil, and it's not the temperature that creates the gold to precipitate, it's the boiling. And so what you need to do is change that pressure, drop that pressure drastically to create the instantaneous boiling. The classic model for the boiling event is these hot fluids come up, they interact with groundwater, that groundwater creates steam, an explosion. And of course, in that explosion, after it's over, it creates a drop in pressure, and that water instantaneously boils and you get gold. But that reaction would only take place near a surface. And so your boiling window is one window near a surface. The thing about an extension regime is an extension is exactly that. The crust is expanding, it's being pulled apart. And as soon as you pull it apart, it creates a drop in pressure. So if you have fluids that are at a high temperature, now you're getting boiling. And so that boiling will not just take place at surface. That boiling can take place at multiple depths and over much greater windows than in the classic model of the boiling event only taking place near surface where there's an interaction with groundwater. So with an extension regime, you can get that drop in pressure and hence the boiling over much greater depth extents and over, say, multiple episodes. And so it's a key ingredient of potentially forming larger boiling windows and hence potential gold systems as well as higher grade, because there could be repeated expansion there.
Thank you for the thorough explanation. There's a couple questions from an individual on a chat forum, so I'll address those right now. Why did we not continue drilling northeast from hole 16 and 17?
Okay, well, I'm not sure whether you mean more eastward in this direction or northeast, but we had sort of pre-planned holes to test certain near-surface IP chargeabilities combined with information we saw on surface. So we didn't want to move too far away from that. So eventually, if you're meaning northeast, following it this way, yes, we will. But we only had a limited drill program. And so the idea was to test as many features with that 500 or 600 meter program rather than specifically start heading in one direction just because we saw good mineralization. And as I say, it's also a lot of it's in hindsight. Once you go back and see the other drill core, you can begin to piece things together. But the idea was to test some IP targets underneath the original trench in a new area that showed visible gold on surface in this area, as well as we had IP in there. So these holes were pre-planned, and it looks very promising moving in this direction following the surface gold. And I'll show you in a minute a nice IP continuing to the east. But the idea was to also drill underneath the western portion of the trench. We believe somewhere to the west there's a north-south structure feeding this mineralization. And so the idea was just to pick a few holes going west and to see if we can start finding those structures and better gold. And we actually did that. Hole number 18. That hole was the one that hit 2 pieces of visible gold. One was right at the top, either a boulder or the very top of the bedrock, and which is exactly where that contact, that stratiform mineralization, is projected to surface. And the other visible gold was lower down. And then these last 2 holes to the west, at that time we really had already met our drilling budget of 500 meters, but we felt we had room to expand it and drill perhaps 100 more meters. And the idea was to either go back into this area and further delineate this target, or try to push the idea west. And it was actually the prospector that twisted my arm. I mean, I like this area too, but Jeff, the prospector, was very excited by some rocks that have been already exposed. What we put in the drill road, and good thing that we did drill here, because again, that was another hole with visible gold right at the top, and it was one of the ones. The vein is kind of interesting because you just look at the vein, it doesn't look very interesting, but it had more VG in it than any of the other quartz veins that we saw in drill core on surface. So, we had a kind of a plan. We had a little bit of leeway at the end, and we decided to go west rather than go east. But I'm sure we will in the future work our way east and northeast, and I'll show you why. Here is now a chargeability down at the 40-meter level, and I say this red polygon, which is the stratiform mineralization. Now, if we now add it up to the 40-meter depth section on the chargeability, it would suggest that it continues in this direction. And you can see how it follows the projected contact of that stratiform horizon where it reaches surface. And so it suggests that a little bit at depth, it picks up some quite nice sulfide. So we'll certainly start following this stratiform type mineralization, stratabound type mineralization to the east.
Well, that makes sense. Thank you. And it's nice that you have the visuals up to help out with that explanation. He had a follow-up question on a different hole. Why did hole 19 miss if slice depth was at 80 meters and top slice was at 40 to 50 meters?
So I'll go back. Okay, well, this is, geophysics, as any geologist will tell you, is not an exact science. It's just a tool. You don't hit every anomaly. In this case, too, the original survey was run parallel to these north-south structures, and so they're a little bit harder to place. And this is what we call an offline anomaly. Here's the line, and simply when you look at the 2D section of the line, you can see something. It's not very strong, and that tells the geophysicist and the modeling program that there's something to the side. But it's just hard to pinpoint exactly where it is. Is it here? Is it over here? Or is it actually over on this side? So we gambled on drilling this offline anomaly just because we felt that there is a structure continuing somewhere up here at depth. In this case, not a lot of joy at all. We'll go back and have a look at the hole in detail. There may have been a little bit of alteration down in this area, which tells us we're close. So sometimes IP anomalies aren't there. It's what we call false positives in the exploration world. It doesn't mean there's not a structure there. It just means you got to go back and with the data we have and figure out how we're going to go at it. And it may actually be a combination of several structures. What we've seen from other geophysics is sometimes when you get structures reasonably close together, it blurs it together and creates an anomaly essentially in between where the true anomalies were. So what we're going to do is actually, in one of the future drill programs, is to get closer to these gold occurrences on surface and drill them very shallowly, 10, 20, 30 meters deep, just like we hit these guys, and kind of get an idea of where they go and then start following them deeper. What we try to do is go for the home run right off the bat, step back and drill deeper. And also this hole, it wasn't drilled in the optimal direction for the structure, but we had another IP anomaly, again, offline, sitting up in here. So we said, okay, well, let's try to hit multiple IP anomalies on the way down to this target. And unfortunately, it didn't work out for either of them. But I say that was only 1 out of 8 holes that missed. So not too unhappy at the end of the day, but we just got to go back and guess probably snuggle up closer to these occurrences and start following them down, just like we did in this cluster.
Great. Thanks for that, Ian. Now I'm going to address the questions in the Q&A chat in the most logical way possible. So I'm going to lead with Nate's question here. What level was the visual gold found at that was released?
The visual gold was found, okay, so going back to hole number, cursor here, 18, that was found at the very top of the hole, essentially within the casing, which is a larger, it's not the main driller. They put a bigger pipe down first before they get into bedrock. So that was intersected in the first meter, and it may have been a boulder or it may have been the very top of bedrock. You don't really know at that stage because the top of bedrock is weathered as well and often breaks off. So this was found right at the top of the hole. In hole 21, this visible gold was really shallow at about 1.5 meters. So we were actually drilling into an embankment. I'll show you actually if I have a picture of it. Yep. So this is the drill road, and just off to the right hand side there's a rock escarpment, rock outcrop, and we saw a little bit of stockwork veining in it, but it didn't look too exciting. And so this is the one that the prospector pushed my arm to set up here and drill into this outcrop and further at depth. And so say that one hit at 1.5 meters down. Hole 18, the other one is at about 32 meters down the hole, so vertical depth, so that would be about 20 meters. And the other guys in hole 16, again, that was 32 meters. One was 32 meters down holes, so that would be about 30 meters vertical depth. And I forget where the other one was. So 2 very, very near surface over here, and the other one's at roughly sort of at 20 to 30 meters depth.
Thank you. Jamak01 has a question here. Does the initial drill program continue to validate the alkaline model with which you've been working? Can you elaborate if so?
It doesn't. The chemistry will help us more with that. How much tellurium do we have? How much potassium? So the drilling itself doesn't further that model, or it doesn't discredit it either. The alkaline concept is more of a bigger picture thing where you look at, the overall potassium, what we call metasomatism in the area, some of the minerals that we're seeing, the fairly high, in this case, gold to silver ratio. Most low sulfidation have a lot of silver. We do on the fringe of to the north of Conquest, we have a lot of silver, but in this area we don't. So that suggests it's alkaline, and of course the telluride. So the drill program itself at the moment doesn't add or dissuade from that alkaline system. That's more of a bigger picture type of thing. But once we get the chemistry back, that might help reinforce that interpretation of an alkaline system.
Great. And he has a follow-up question here. Any sense about when the follow-up drill program will commence?
No, I mean, we ideally, obviously, would like to wait for assays, which may be 2 to 4 weeks away. Then it's a matter of financing that, hopefully on the backs of results, good results. I'd like to get one more in before Christmas. Essentially, we have targets picked out already. We'll have to go and fine tune them, but some of it will be back in, 1 or 2 more holes in this immediate area. We'd like to follow this eastward, and there's a really nice target at depth, which we think is the same structure that had the gold in hole number 18 is dipping down to the west, and we think we could sit up here and drill into it. And I say that really nice IP target that we had with a very, very low resistivity sitting on top of a high resistivity. So we already got targets picked out. and I'd like to get to another program before Christmas, so sort of very late November, beginning of December. Fingers crossed. If not, we'll get back to it as soon as we can in the new year. And snow here is not usually a problem, but I would like to get back right away. It would be nice to have the assays just to help pinpoint more drilling in this area and understand it from that. But there's enough targets, that we can go back and drill right away. And we know there's going to be gold in these samples to some degree. We don't know whether they're 1 gram, 0.1, or 100 grams. But clearly they're part of what looks like a very fertile epithermal system. And more drilling needs to be done. And I'd like to get onto that as soon as possible.
Yeah, that makes sense logically to wait for the assay results.
Yeah, just while I get this image out too, I mean, I say the chemistry of this stratabound mineralization, as we're calling it now, we think it's there, as a very distinct chemistry. And you can actually see it here. I've also plotted in the blue here antimony, which we know is a really good pathfinder for epithermal systems. And we see it sort of come and go at Root Cellar. Hole number 6, which is further east of here, and where we're seeing a lot of visible gold boulders, but we haven't found it on surface yet. When I look at the chemistry, now that we know that this stratabound mineralization occurs, and then we can project along based on geophysics, and actually this little creek, which you can see behind the geophysics here, is more or less the contact of that basalt to the andesite. And if I go along to hole number 6, where we're getting the visible gold, we look at that hole number 6, and it doesn't have any antimony in it. So we only look at the other drill holes. We know that the mineralization within that stratabound unit carries antimony. We get below it, and it doesn't. So I go back and look at hole number 6, look at the geology, look at the chemistry. We can say, okay, we undercut it. We were below it, in which case we were never going to hit it. So if you go back to this guy, so hole number 6, because we didn't know of this stratiform horizon at the time, we would have drilled up sort of here, and we would have been underneath it. So we got all the low-grade mineralization, but we never hit the main target. So we'll go back to hole number 6 area and drill the other way around. Now it's still not quite as easy as that, but at least we know that there is that in that case we undercut the horizon, and now we can just position ourselves better to make sure we get that gets at least that layer. Now this layer as well is not all going to be uniform in its gold grade. It's still, this layer is getting its mineralization from structures, both east-west and north-south. So once we be able to project those structures back into this stratabound horizon, that's where we should get your higher grade gold. And so that was one other, as a thing from this drill program, is we now kind of define this layer, and now with the geophysics, past drilling, and the structure, we should be able to target the sweet spots a lot better. But certainly hole number 6, we now know we drilled underneath it and never came through this horizon.
My apologies, Ian. I should have asked this before we went live. Was there a hard stop at this time, or could you answer another 5 questions or so? We have still about.
I can answer another 5 questions. Yeah.
Perfect. Going back to the assay results, Steve was wondering the schedule of the assays. Are you going to release them all at once, and probably the timeline as well?
Well, I'll say that the estimated turnaround time from the lab is 2 to 4 weeks. We're going to try to rush some samples, but a very limited number of samples. So we'll probably release them in batches, providing they're meaningful. Like they should come in as like a certain amount of drill holes rather than scattered. And so as long as we can piece together, half the drill holes or something on that magnitude, we'll release them in batches. But it's on. We've been told the turnaround is 2 to 4 weeks, which isn't bad. So fingers crossed that it's not much more than that. And I would say we will be getting some a little bit sooner. And more samples are going in from surface. As I say, the prospector, once we hit that visible gold at the top of hole number 21, he immediately went back and was channel sampling on that area. Saw some nice looking rocks. We'll send up some photos the next few days. No visible gold that he saw so far, but again, really good looking rocks and textures that we just haven't seen before. So this thing is expanding. Now that we're getting the hang of this thing, it seems like we're, positive results from drilling and surface sampling should be much more regular right now, because I really felt we've hit a pivot point here. Even before the drilling, a lot of the observations we made in that trench made a lot of sense, and now from the drilling, it's coming together nicely, and I think we're going to start picking off these near surface IP targets with much better success rates. The deeper ones, again, might require a little bit more drilling, but we feel this drill program has really been a pivot point in our understanding of this. And it was really just last night that the geological crew figured out this contact style, or sort of stratabound mineralized pod, and its relationship to the lithology, and that even the geology itself helps us a lot to sort of go and figure out what's happening with these structures and with the geophysics. We always knew the rhyolites were important for a different reason. Now we see these rhyolite spires or rhyolite dikes seem to be controlling some of the mineralization as well. And I say they change really quickly from what you see on surface to a few meters down. So we've learned a lot the last few days, and from the drill program. I say it's we're all very motivated to get back and do some more drilling.
Great. So there's a handful of questions here that aren't drill program or exploration related, so we'll get to these now. One of the questions is, which neighbors are potential suitors for when your resource is established?
Who?
Sorry, which neighbors are potential suitors for when your resource is established?
Neighbors, well, there's no real neighbors to us in this immediate area. Partners, I mean, we hope it's one of the bigger gold companies. At some point we're going to start following the copper. At one point I was planning to test a few of the copper targets in this program, but we were honestly having too much fun in the conquest zone to start moving off, and we began to learn a lot. So it's like, okay, let's not dilute the story. We'll follow the copper another time. But hopefully it's one of the bigger gold producers. I think this project has the scale capability as we've seen from the surface footprint, and we've just been focusing on the conquest. Don't forget, we've got Drop Zone and Windfall and Braxton Bradley, and these may not be physically connected, but they're probably all related. And you go to some of these big copper systems in the Pacific Rim and places, there's a lot of other, and you just get a lot of gold activity in these volcanic centers. And the ones on the north flank of Root Cellar are slightly different style. They're probably intermediate, but again, in these big systems, you're going to get a variety of styles of flow sulfidation, and we certainly see a lot of brecciation. And I say that's quite common in these, especially these extension regimes, and especially some of these deposits in Java, Indonesia. I was reading a paper the other night that some of more of their gold comes from these brecciated systems, or brecciated portions of the systems than the coliform crustiform vein. So, this kind of took us by surprise. We were expecting to see nice coliform crustiform veins, and we just got this, dog's breakfast of breccias, and these oatmeal breccias, as we call them. But they're pretty neat because, every brecciation event brings in has the opportunity to bring in gold.
Thank you. There's a question about how close are you to earning your full interest at Root Cellar?
By the end of the drill program, we just got to tally up all the things, but we would have met our expenditure requirements, are very, very close to it, extremely close to it. And then it's just a matter of making the last payment to the prospector. So essentially the work commitments, which are the biggest thing, would be either have met or extremely close down to the last, $10 or $20,000. But I think we're going to hit that threshold by the time we've tallied all the bills from this drill project.
And Nate is wondering if you have any further guidance on the CRA or Quebec government or whichever it was.
No, I mean, no, I don't really want to go into that too detail, other than, the court proceeding allowed us to file an objection, and we're going through that process. We hope it's going to go quickly. We think it will. But as we all know, government agencies, when it comes back to giving back your money, they're not the quickest. But I want it to proceed as fast as possible to you. But so that we're in the objection process. It's just a matter of going back and forth with their agents and our lawyer. But I don't want to comment too much publicly. It's not, a true. It's not in the courts anymore, but I consider it a quasi-judicial process, and I just don't want it to be played out in public. But we're following the objection process, and hopefully they process our request quickly.
No, fair enough. Have you done any investigation on your stock price? An individual here is wondering if you reckon there's any manipulation by one or two firms. Based off his comments, he says it looks like that's the way, based off how it's trading.
Well, not specifically. I mean, I think the sell-off last week on the news release may have been one of the funds liquidating their position, just because some of these funds, unfortunately, use good news as a way to get out. But I don't think anyone's otherwise manipulating it. I'll take a closer look at it. It was a little bit, of a slap in the face to see the price take the hit last week when the news came out, because it was, say, we've hit 7 out of 8 drill holes with 3 with visible gold. But unfortunately, this is the way the markets treat junior mining companies right now. But I think it's just short-term pain. It's frustrating. I feel your pain, but I'll look into it. But I'm not going to lose too much sleep over it. I think we're on to better things here.
Definitely. Ian, that's it for the questions in the chat. So thank you all that have participated, and especially the ones that submitted questions. The recording will be available most likely today or tomorrow, so keep an eye out for that if you came in a little late. But I'll leave it to you, Ian, to say the final few words.
Yeah, as I say, we're we like that we see a drill core. It wasn't all what we were expecting, but that's actually good news. We saw a lot of new stuff, which makes us very optimistic. As I said, we feel we've turned a corner here, and we understand the geophysics better, the geology better, and we feel we're going to be picking off these geophysical targets with a lot more regularity as soon as we get back on the ground. And I believe there's something significant here, and we're going to be focusing on this a lot in the coming years.